So this lesson is going to focus on introducing what a quadratic relationship is called, and then the parabola that results when we graph it. So we will be looking at graphs, table of values, and equations, and using these recognition points to identify if it's a quadratic or not. So let's start off with an example. So we are going to complete our table of values and then use it to graph. So we have y equals x squared. So this is our base function, if you want to call it that, or our base relationship. It's the most simple one we're going to have. Just like when we're graphing a line, y equals x, one of the most straightforward ones that we have. So to populate the table, I'm going to take -2 and I'm going to square it because that's what the relationship is. So -2 squared is 4. -1 squared is 1. 0 squared is 0. 1 squared is 1. Then we get 4. So when I plot these points, so I have a point at 0, 0, -1, 1, -2, and 4, 1, 1, and 2, and 4. So I've graphed this here, and then I am going to connect the dots. Okay, so you see it's definitely not a line, because we can't connect all of those points using a single line. So it curves a little bit. Now if you think it back to grade 9, one of the ways that you could tell if something was linear was to find the first differences. So let's look at this here and see what happens when we find the first differences. So 1 subtract 4 is -3, 0 subtract 1 is -1, 1 subtract 0 is 1, and 4 subtract 1 is 3. So these first differences, they're not the same, so it's not linear. That shouldn't come as a shock based on what we have on the screen. Then I'm going to calculate the second differences. So I'm going to take the differences of the first differences. So -1 subtract -3 gives me a value of 2. 1 subtract -1 gives me a value of 2. And 3 subtract 1 gives me a value of 2. So these second differences are the same. Keep that in mind. Now we're going to answer a couple of questions. When I scroll down, so calculate the first differences, we did that. What do you notice? They are not the same. The second differences, what do you notice? They are the same. And then the final question is identify the y-intercept. So the y-intercept is where it's touching the y-axis. So that value is 0, 0. Okay, so that's one. Let's do another one. So we have y equals -2x squared. So this time I have to multiply whatever I get when I square x by -2. So I'm simply substituting in. So -2 squared is 4, multiplied by -2 is going to be -8. -1 squared is 1, multiplied by -2 is -2. This is still going to be 0. This is going to be -2. This is also going to be -8. So when I graph this equation, you'll notice something different. It is going in the opposite direction. So this is pointing downwards. Okay? And if you want, you can check to make sure that the points are on the parabola that we've graphed there. So now, just like the other example, I'm going to calculate the first differences. So -2 subtract -8 is going to be 6. 0 subtract -2 is 2. -2 subtract 0 is -2. And -8 subtract -2 is -6. So they are not the same. Now we are going to do our second differences, sorry. So 2 subtract 6 is -4. -2 subtract 2 is -4. And then -6 subtract -2 is -4. So once again, not the same. Same for the second differences. And our y-intercept is once again 0, 0. All right, our third example. So this one here is going to take a little bit longer. So basically what we're doing is we're doing y equals -2 squared minus 4 multiplied by -2 plus 1. So I have to do that with each of the x values. So I get 4 plus 8 plus 1. So that equals 13. So that's actually off my grid a little bit. If you do the same thing with -1, so -1 squared is 1, plus 4 is 5, plus 1 is 6. This is going to be 1. Okay, so when I do 1, I'm going to have 1, subtract 4 is -3, plus 1 is -2. And then the last one, I'm going to have 4 minus 8 is -4, plus 1 is -3. All right, so then when I graph this here, see that it's going to go off a little bit. So at -2, it's not actually plotted there correctly. Or sorry, it's correct, it's just it's not showing it. So I'm going to check my differences. So the first difference is 6 subtract 13 is -7. 1 subtract 6 is -5. -2 subtract 1 is -3. And then -3 subtract -2 is -1. So then we do our second differences. -5 subtract -7 is 2. -3 subtract -5 is 2. -1 subtract -3 is 2. Once again, not the same. These are the same. And when we look at it, the y-intercept is actually at 0, 1. Okay, so this is the last one we're going to do before we start drawing some conclusions. So here, when I substitute in -2, so I'll have -2 squared is 4 times -3 is -12 plus 3 is going to be -9. So then we are going to have -3 plus 3 is 0. Then we have 3. Then we have 0 once again. And then we have -9 again. So when we graph this here, this is what our graph looks like. So just like our other examples, we are going to check our differences. So 0 subtract -9 is 9. 3 subtract 0 is 3. 0 subtract 3 is -3. And -9 subtract 0 is -9. Then we're going to do our first differences. So we get -6, -6, -6. So it shouldn't come as a surprise that they are not the same for the first, but they are the same for the second. And when we look at our graph, our y-intercept this time is at 3. So we have the coordinate 0, 3. So recognizing quadratics. So any relation that has a degree of 2 is going to be a quadratic. So that means the degree of 2, the highest number, is going to be 2 in terms of the exponents. Okay. From a table of values, the second differences must be the same, but not 0 for it to be a quadratic. And then from a graph, if it looks like this, where you have a minimum or maximum value, that is going to be an example of a quadratic. So what conclusions can we make? This is called a standard form. We are going to look at 2 other forms of the equation of a quadratic, but this one here is specifically called the standard, which is what we were working with today. This a value, so the number in front of the x squared, that's always going to tell us if it's going to be opening upwards or downwards. So if it's positive, it opens upwards. If it's negative, it opens downwards. The last thing that this form of the equation tells us, just by looking at it, is what the y-intercept is. To find the y-intercept, you let x equal 0. So the ax squared goes away, the bx goes away, you're left with c. So this number right here will always be the y-intercept. So here's a couple of equations. So given the following equations, identify the direction of opening and the y-intercept. So a is greater than 0, therefore it's up. There is no C value, so this is like there's a plus 0. So that means our y-intercept is at 0, 0. Once again, make sure you're using those brackets to show that it's a coordinate. All right, and then this example, so A is less than 0, therefore it's down. And then we look at this number right here. So the y-intercept is at 0, -4. All right, so that concludes this lesson. So hopefully it makes sense. It's just the very, very beginning, and we'll be working through way, way more examples.